All right, so today what we're going to talk about is the average atomic mass. So if we look at our periodic table, right, something like chlorine, right, we have our atomic number on there that is 17. But when we look at the atomic mass, we see that it's not a whole number. Instead, it's 35.61. Okay? So what we see on our periodic table is that the atomic mass is not a whole number. And the reason why is because we have an average atomic mass, right? So the atomic mass that is on our periodic table is the weighted average of an element's naturally occurring isotopes, okay? So we've talked about how we have lots of different isotopes. Those isotopes arise from having the same number of protons but differing numbers of neutrons, okay? And so what we have on the periodic table is a weighted average of all of the elements over all the world, right? So wherever we have found a chlorine atom, it doesn't have a mass of 35.61. Instead, the average of all the chlorine atoms have an average of 35.61. So what we need to do is we need to use a weighted average formula, okay? So what the formula is the percent abundance of an isotope. We're going to use a decimal form, that's really important, not the whole number form. Then we're going to multiply it by the mass of isotope 1, okay? Then we're going to add the percent abundance of isotope 2 times the mass of isotope 2, plus the percent abundance of isotope 3, mass of isotope 3, however many we have, we're going to add them all together, and then that should give us the average atomic mass of the element, okay? So let's go through this example, right? Our example here is chlorine, right? Chlorine has two naturally occurring isotopes. One of them is chlorine 35, the other is chlorine 37. The exact isotopic mass of chlorine 35 is 34.9689, okay? Exact isotopic mass of chlorine 37 is 36.9659, okay? These are our exact masses, so we're going to need those, and then we need our percentages, okay? So for chlorine 35, we're going to take our exact isotopic mass, and we're going to multiply it by the decimal form of the percentage, okay? So chlorine 35, right, is 67% of all the chlorine atoms. 67.49% when we write it as a decimal, right? We move this decimal over 2 spots. We have 60.6749. We're going to multiply it by our isotopic mass, right? When we do that, we get 23.6. All right? Then we do the same thing for chlorine 37, okay? So chlorine 37, the exact isotopic mass is 36.9659, and then the percentage that's chlorine 37 is 32.51%. So we move the decimal over 2 spots. We have the decimal form of the percent abundance. We do 36.96 times 0.3259. That gives me 12.01. These, right? So we take those two numbers then and we add them together. When we add them together, right, we get 35.61. That's exactly what we said is on our periodic table, okay? So let's go through another example here, all right? If we have two different isotopes, right, and we don't have the exact masses, what we're going to say is that, well, carbon is carbon-12. That's close enough, okay? So we have two different isotopes that we generally see of carbon. It's carbon-12 and carbon-13, okay? We take, to solve for the average atomic mass, what we're going to do is we're going to take our 98.89%, that's carbon-12. We're going to take our isotopic mass of 12 times 0.9889. We multiply those two together, we get a number. We have carbon-13, that's 1.11%. So we move the decimal place over 2 spots. Be careful here. Make sure that we have the 0 in front, right? 0.0111, because when we move this over 2 decimal spots, we have to get that extra 0 in there. So 13 times 0.0111 is 0.1443. We add those two numbers together, we get 12.01. That's what we have on the periodic table. Okay? So we have a few practice pieces on the next pages. You should be able to calculate our average atomic masses on those.